Now that you've seen what the magic formula is, let's dive deeper and explore how it comes about. So we start with our position vector, ROP, and ROP is written as the sum of two vectors, one in frame A, so that's ROR, and one in frame B. So again, this is frame A, and then this here is written in frame B. Now to get the velocity, we just went through this in the last video, but I'll quickly do it again for completeness. So we want the velocity of point P in frame A. So we take the time derivative of our position vector, ROP, in frame A, which is equal to the time derivative in frame A of ROR plus RP, which is equal to, we can separate these terms out, so we can take the time derivative of ROR in frame A plus the time derivative of RP in frame A. Now, this portion here, this term here is straightforward. We can simply rewrite that as using the following notation: the velocity of point of point R in frame A. And then for this term here, we can write that using the magic formula, because again, this is expressed in frame B. So then we can write plus the time derivative of RP plus the angular velocity of frame B and frame A crossed with the position vector RP. And we can simplify this term here and now write, just change the notation, so we have the velocity of point P is equal to the velocity of point R in frame A plus the velocity of point P in frame B plus, again, our angular velocity term crossed with our position vector RP. So this here is our velocity term. And then we're going to use that to get the, to derive acceleration. Now that we've cleared some space, let's go ahead and derive the acceleration from this velocity equation. So to get acceleration of point P in frame A, taking the time derivative of the velocity of point P in frame A, all in frame A. So just to write that out here, taking the time derivative in frame A of the velocity of R in frame A plus the velocity of P in frame B plus the angular velocity crossed with our position vector RP. And now let's just break up the terms here. So we have the time derivative in frame A of the velocity of R in frame A. And we have the time derivative in frame A of the velocity of point P in frame B plus the time derivative of, in frame A, of our angular velocity crossed with our position vector here. And so we're going to do one more simplifying step, and that is we can take this term here, and we can simplify the notation. We can write this term here as simply the acceleration of point R and point P. So that's going to leave us with, again, these two additional terms, which I'm just quickly writing out. Okay. So this term here is, oops, frame A. This term here is in its final notation. So now we're just going to look at each of these terms separately, just because it does get a little, the algebra gets a little hairy. So we'll first focus on this term here. So taking the time derivative in frame A of our velocity of point P in frame B. So this term here can be written out using the magic formula. So we take the time derivative in frame B of our velocity of point P in frame B plus the cross product of our angular velocity and again our velocity of point P in frame B. Then we can simplify the notation of this term. We can write that now simply as the acceleration of point P in frame B. And then we have here our angular velocity crossed with our velocity of point P in frame B. Okay, so now we have this term, which I'll show in a moment, we can plug in here. Next, we're going to tackle this term, which is a little bit hairier. So we have the time derivative in frame A of our angular velocity of frame B in frame A crossed with our position vector RP. And to take this derivative, we're going to utilize the product rule, which hopefully you remember, but if not, I'll just write it again. So our derivative of AB is equal to the derivative of A times B plus A times the derivative of B. Right? And the same rule applies when we're taking this cross product here, because again, the cross product is like the multiplication of vectors. Okay, so that means we take the time derivative in frame A of our angular velocity crossed with our position vector RP plus our angular velocity term crossed with the time derivative of our position vector RP. So now this term here, in terms of notation, simplifies to the angular acceleration of frame B in frame A. Again, I defined the angular acceleration in the prior video. This should make sense. Angular acceleration is the time derivative of angular velocity. So again, that's crossed with our RP. Plus we have our angular velocity here, and we're crossing that. Now again, position vector RRP is written in terms of the unit vectors of frame B, so we have to use the magic formula here. So here we'll take the time derivative in frame B of RP plus the angular velocity crossed with RP again. So we can rewrite this and simplify at least one of the terms. So we can take this time derivative in frame B of RP and simply write that as V, the velocity of point P in frame B. So again, that's just a notational simplification. And then of course we write out the remaining terms. And then the last step is to, well, we write this term out first. And now we have to distribute this cross product. So we take the cross product between the angular velocity here and this first term, as well as the cross product between the angular velocity and the second term. So just to write that out, we have plus the cross product between the angular velocity and the velocity of point P in frame B, plus, I'm just going to write this down here, plus we have the angular velocity of point B in frame A crossed with, again, the angular velocity of frame B in frame A crossed with our position vector RP. And then, right, so this here is equal to this term. So to get our magic formula, we're just simply plugging in this long term into here. And then, of course, this term that was derived up here down here. So to clean this up and to write this one more time, we had the acceleration of point P in frame A. It was equal to the acceleration of point R in frame A plus, and we had the time derivative in frame A of point P in frame B plus the time derivative in frame A of the angular velocity in frame B with respect to A crossed with our position vector RP. And then we plug in those terms, and what we get, I'll make this nice and bold. Again, we plug in those terms, and what we get is the following. We have AAR plus the acceleration of point P in frame B plus angular acceleration of frame B in frame A crossed with the velocity of point P in frame B plus the angular acceleration of frame B in frame A crossed with our position vector plus the angular velocity crossed with our velocity of point P in frame B plus our angular velocity crossed with our angular velocity crossed with our position vector. And there's one more simplifying step. You see that these two terms here are the same. So lastly, we can just rewrite this out, combining those terms. Okay, so now we have 2 of this term plus all of the remaining terms. Now you may be saying to yourself, woof, what a formula, right? This is really long. How am I going to remember this? Will this help me on a homework or quiz or exam? The idea is you would have this formula, right? And you can use this as a guide. So even though the formula itself looks long and daunting, the advantage of using this formula is that you know exactly what terms you have to calculate so you can quickly get to your final acceleration that you want. And so I'll show you in the next 2 videos just examples of how we can actually use this super magic formula to make our lives easier.